All right. So so far, what do we know about the instructions? We know their addressing mode. Just by looking at the instruction, we can identify the addressing mode, and also we are now able to write their object codes. Something like what we see here. This is a snapshot of what we understand so far, because all the instructions when you write in the compiler after the compilation or after the assembling process is done by the assembler, what happens? For an example, let's say you have written these 4 lines. Do you see the source code? These are the 4 lines, let's say you have written. At this point, you don't understand what they mean. You don't even understand what they are doing. But let's say we have written this. So now we know exactly what will be their object code. For an example here, look at this. We have written the object codes for those. And as you know, that instructions, the object codes of the instruction vary from 1 byte to 3 bytes. Because the inherents are 1 byte. Extendeds are 3 bytes. Some of the immediates are also 3 bytes. Most of those are 2 bytes. It depends on. But at the same time, we also understand. For an example, let's say when you compile, all the object code basically are loaded into the computer, right? I'm saying into, let's say, memory locations. Remember, in general, when I mention memory locations, that means I'm talking about the RAM. Okay. Unless I mention that's a register, because the register is inside the microprocessor. The memory locations is in a separate place, which is RAM. Now, and also we understand that since they take bytes, because anytime you're writing something, they will be allocating the memory space. So, for an example, the first instruction is 2 byte. So it started from 0000, let's say. Just assume that it started from here. So automatically the next instructions will be starting from 0002, right? Because it's taking 0001, and this is what? 0001. This is 0000, and this is 0001. So this is going to be 0002. This is going to be 0003. This is going to be 4, so that's why the starting location is 4, right? So these are the starting locations of basically these locations. So for an example, 00 is the location of 96. 0002 is the location of 9B. You see what I'm saying? 0004 is the starting location of this instruction, which is B7. Last one is 3. So I think we understand this so far, right? We understand that how the memory locations, for an example, these are consecutive locations, consecutive bytes, because the way you are writing the instructions, based on that, some instructions are taking 2 bytes, some instructions are taking 1 byte, some instructions are taking 3 bytes. We understand it because we now know how to write the object codes. And this is exactly how the bytes are basically will be allocated. But it may not be starting from 0000. We need some more understanding to know exactly where the byte will be starting. We don't know exactly where the byte will be starting right now. But I'm just, as an assumption, let's say we're starting from the first location, which is 0000. So this is what we know so far. Anyone disagree? So, and also we know that to write the object code, we also need the addressing mode. So, automatically the addressing mode comes into the picture because you cannot write the object code without knowing the addressing mode. Now, let's see what we can extend today. So far we know that every instruction has addressing mode. But the next question probably we want to ask, what do we mean by the addressing modes? What are the meanings? Because the addressing mode, we have seen that every instruction has like 3-4 different types of addressing mode, 4-5-6 different types of addressing mode. It has immediate, direct, extended, indexed, some more extended, inherent. No, not inherent, because the one that you have immediate, it cannot have inherent, but there are variations, right? Now the question is, what do we mean by this addressing mode? We know that they look a little bit different because some of those have like pound sign in the operand, a little bit different, but still we don't understand it. So today probably we'll make our first effort to understand it. Remember, we'll not be done, but we'll probably start here to understand the instruction. That's exactly what the intention is. Now, first of all, as we know that every instruction has two parts, right? Opcode, operand. Sure? There are two parts, right? Except inherent, because inherent instructions do not have operand. Okay? So, let's say we are talking about the operand. Now, just by looking at the operand, we see that most of the cases the operand is a number, right? I'm saying maybe the number is written in binary, or maybe it's written in decimal, or maybe it's written in hex. Doesn't matter what number system it is, it's just a number. I'm saying number system doesn't matter how you write, but since even in the object code, we are writing only the hex, but at the end, that's just a number. Now, we don't know exactly what that number means. Now, remember, as you remember from the very first day when we are first exploring the microprocessor, how it works, and we tried to show you a schematic of little bit of how the microprocessor works. Remember, there were only two different types of number. One was data. Remember the 8-bit data. We said that the data can be 8-bit. Everything we are saying that those apply only to the microprocessor will be working in the lab, the Motorola microprocessor. Don't assume that all microprocessor deals with 8-bit data, because the microprocessor we have inside this computer, they deal with 64-bit data, so it's not exactly the one. But it doesn't matter. At the end, once we understand it, we can figure it out what happens in every microprocessor. So here, the number can be either data or can be address. Because, we remember, these are the only two things we have which has number. Because for an example here, even if you remember the last slide, we just what you have covered and those things. What are the numbers? Either it can be an address of the memory location. Let's go back. Let's see. Look at this. These are numbers, right? These are also numbers. Now, exactly, just by looking at these people, all these are numbers and all these are written in hex. So the operand can be either number, I'm saying data, or address. We don't know exactly which one is address and which one is data at this point, but the addressing mode is the one that will tell us, that basically tell us that whether the operand is a data or an address. Now the first effort we will be making to understand the instruction is to identify whether that is a data or that is an address. Now I tried to give you a little chart here at the bottom of this slide to just give you an idea that which addressing mode is telling what. Okay. Now let's say the immediate. Immediate, you will always have the data. Okay. So whatever the operand it is, that's data. That is always data. Now, it can be 1 byte or 2 byte, 1 byte or 2 bytes, right? Based on how it is, it can be either 1 byte or 2 bytes. Because we know that some immediates are 1 byte, some immediates are 2 byte, but it's a data. Direct and extended, they are address. So, now we can see that, okay, why the addressing mode has to be different. And why this is a huge difference, because you are at some point you are talking about the address, at some point you are talking about data, right? So direct and extended, both of these are address. Now, in direct, you are writing the address in 1 byte. In extended, you are writing the address in 2 byte. Now you might be wondering that why, because you know that the addresses are 2 byte, right? I'm saying because those are 16 lines. Remember the microprocessor design, we had 16 lines. So it might be a little bit wondering that why we are writing the address in 1 byte. Because it's 2 byte. Some of the address you can still write it in 1 byte. For an example, your address is, let's say, 0006. Instead of writing 0006, you can only write 06, right? But I'm saying technically there's the same number, right? So that's why sometimes, and what you are basically saving, because you can still write the address as 0006. But instead of writing 0006, you can write only 06. You are basically saving 1 byte of memory location. You can always use extended, but probably you are using direct to save that address. And inherent, we can ignore inherent, because the inherent there is no operand, so we don't have that issue come into the picture at this point for inherent. So we can ignore inherent for now. So remember, immediate, the operand is always data. Extended or direct, operand is address. So, we are just making little step at a time. We don't want to understand too much, but at the same time, make sure you always finish the homework before we start the next lecture, because what will happen is, if you don't understand the previous part, it will be harder, and at some point it will be hardest for you to understand the next topic, okay? Because the way we designed it, even you saw in the pause, you cannot even see the homeworks, quizzes, the next ones, if you are not ready, because we don't want to scare you. And scare ourselves, because if you don't understand, we'll be also scared, because we don't want to confuse each other. Now, let's look at a little bit more steps. So, now, we'll look at one specific type of instruction here, which are called load instructions. As you know that in those 6 pages of instructions, there are plenty of instructions, right? Now, we are only looking at only one type of instructions, which are called load instructions. Now, what is special about load? Now, the load instructions is highly used instructions, because most of the load instructions, what this do is, this basically loads some data into different places. Now, what do I mean by load? By load, I mean, automatically all the data are in some memory locations, let's say. Okay? By load, I mean the data is being loaded from memory to register, because you remember that all the operations are done in register. What do you mean by operation? Addition. Or logical comparison, because computer cannot do anything else. So all those operations are done in register. Now, before you do the operation, all the data are in the memory location. And what do? Let's say you have 100 bytes of data. Now we only pick probably 2 bytes from there and add them, let's say. So to add those, you first have to pick those and load into register. So to load it, it's basically you are loading into microprocessor. Technically microprocessor means register, because there are registers where you do the operations. So by loading, you mean that you are loading those data into register, and all these instructions basically load. Now, why there are so many instructions for loading? Because remember, we had a couple of different types of registers, right? Remember those registers, the accumulators, index register. I showed you a couple of different registers, right? 5, 6 different types of registers. This is in the same slide at the beginning. So these are loading into different places, different registers. Now for an example, LDAA. That means the load data, again 1 byte, into accumulator A. So what does it mean, LDA? This means load accumulator A. Probably this is how you can read. The next one is load accumulator B. That loads 1 byte into accumulator B. Remember, that 1 byte is really important here, because the accumulator A and accumulator B, those are 1 bytes. So you basically cannot load more than a byte. So because they are 1 bytes. But other ones, look at the last 3. They are 2 bytes, because the registers are the register itself 2 bytes. Okay, they are 2 bytes. So that's why we said load data into index register, load data, but this time the data are 2 bytes. All the data is 2 bytes, because the register itself is a 2 byte, because you can load 2 byte there. But the accumulator A and B, those are 1 byte. So remember that these are the only 2 accumulators. I would say only 2 registers, accumulator A and B. Those are only 1 byte each, except these 2. Everything else, every other register is 2 byte. every other general purpose register, because there are some special purpose register. We'll not be talking about those registers before next semester, so don't worry about those. So you will see only the general purpose register this semester. So except accumulator A and B, all the registers are 2 byte. Now let's look at a real example here. Let's say this is an example. Now first of all, what is the addressing mode here? Say it again. Yeah. But I'm saying, what is the addressing mode? Immediate, right? Immediate, right? Because there is a pound sign and there is no doubt. Now, when it is immediate, what is your data? This is, what is the operand? This is data, right? Do you see it? I marked it. So this is now a data. Now what does it mean? This means load this data to accumulator A. So this is exactly what is going to happen after you are done. Because 177 is B1. I'm talking about hex. Because at this point 177 is in decimal, right? Any doubt? That's in decimal because there is no pound sign. There is no dollar sign, and there is no percentage sign. Because if there is a percentage sign, this is binary. This cannot be binary because there is 7. But if there is a dollar sign, it can be. It will be hex. But there is nothing except pound sign. So that means this is decimal. So we always talk about hex. So the data is in fact B1, which is equivalent of 177. So basically, by this instruction, what happens? B1 will be loaded to accumulator A. This what I'm saying? B1 is going to be loaded into accumulator A. Any question here? Because you said load accumulator A and you gave the data. So just that data, because the reason I'm saying that you gave the data because the addressing mode is immediate. So immediate means the operand is data. So you directly gave a data and you said load this data to accumulator. Now let's look at another example. Next one. Look at this. I remove the pound sign. Now what happens? Still you are loading into accumulator, right? This is probably accumulator B, but it's the same thing because accumulator A and B, both are 1 byte. Now at this point, what is 177 here? Data or an address? This is an address right now because this is direct, right? Remember, only immediate is data. Everything extended and direct are address. So this is an address this time. Now what happens when this is an address? That might be an exciting question. What is loaded into accumulator? Because we know that at the end, something is going to be loaded there, right? We don't know exactly what is loaded. How do I know what will be loaded? Now, what happens is, what is 177? Is B1, right? That's B1. Now remember, B1 itself can be a memory location, right? I'm saying, for an example, let's say you have, a bunch of memories. You have all these bunch of memories, for an example, let's say. All these are 1 byte, remember. This is 1 byte. So for an example, 8-bit, right? This is, let's say, 0000, right? The next one may be 0001. At some point, if you keep continuing like this, because, there are all the way from 0000 to FFFF, right? That will be your last location. So at some point, you might have this. Do you see what I'm saying? At some point, this is going to be B1 as well, right? I'm saying if you keep continuing, there will be plenty of spaces in the middle. At some point, this is going to be B1. Do you see what I'm saying? Now, let's say in the B1, you have, let's say you have this. Let's say you have this data. What is this in hex? 02, right? Look at this. This is 0. I'm assuming that in B1 you have 02. Okay? So by this instruction, 02 is going to be loaded into accumulator B. Because when you are referring to an address, that means whatever you have in that address, whatever data you have, that is going to be loaded into accumulator or into register, whatever register, how you write the instruction. You see what I'm saying? But now, remember, at this point, 177 is an address, which is B1. And for an example, so basically to answer this question, you need to know what we have in B1. You see what I'm saying? Now let's say, for the instance, let's say in B1 we have 02. That is the data you have in the B1. Remember, the B1 is an address. And in that address, the data you have is 02, for an example. By this instruction, do you see those two question mark? That means there will be 02 there. Because the 02, you have the 02 in B1. So now we are ready for quiz 3, but before we go to quiz 3, I just want to show you a snapshot of quiz 3. Let's see whether I can find it here. Just, I know that most of you are done with quiz 2, so you are ready for quiz 3. But just in case, let me show you an example so that exactly what you will see in those questions. Now look at this. In each of the questions, you will see something like this. You will see a memory map. Okay. You will see a memory map. Now what do we mean by memory map? For an example, this is the memory map given to you. We need to know exactly how to read it. Now here, you see here for an example, you see this is 0010, right? That's the address, right? So that means this is the address of this byte. Do you see this is a byte, 58? I'm moving the cursor there. You see it? 58? So this is basically 0010. What is this? 0011. What will be the next one? 00. So basically, all these are different locations. The address is for the first location. From there, you will know exactly what will be the address of next location. Because this is 0010, so this is going to be 0011. This is going to be 0012, 0013, 14, 15, 16, 17, 18, 19, and then what is this? 1A is a hex. That's 1A, right? This is 1B, okay? 1C, I'm talking about the address. 1D, 1E, and 1F. The next one is here, which is 20. Because after 1F, the next number is what? 20, right? I'm just reading the hex in sequence. So we need to know how to read it. So what is B1 right now? Can you show me what is B1? Remember the B1, I was just talking in the lecture. Where is B1? Do you see B1 here? The address B1. Where is the address B1? This is B0, right? Do you see it? This is B0. So this is B1, right? So B1 is what? 2D. 2D is the data. B1 is the address. So each question you will see something like this, and the question will give you an instruction and will tell you what is going to be loaded. Now remember, if that is data, that will be directly loaded. You don't have to even look at the memory map. If that is an address, then you will have to look at the memory map. Now remember, since this is like a quiz, with each and every question we gave you the memory map. You may need it, you may not need it based on the instruction. I'm saying if the instruction is immediate, you will never need the memory map because immediate, your data is there in the instruction, right? If it is not immediate, meaning direct or extended, you'll have to look at the memory map. You have to find that memory location and load the data. So all you need to do is just write that data. For an example, if the question is saying B1, so you know that the B1 is 2D. So your answer should be only 2D. And also just remember, as I said, that some of the memory byte, some of that load instruction, they load 2 bytes, right? Except the accumulator A and B, everything else loads 2 bytes. In those cases, what happens? If the address is B1, what do? You will, because you know there will be 2 bytes, right? But in B1, you have just 1 byte, which is, let's say, 2D here. So B1, you have only 2D for an example. Now what you are going to load? You have to load 2 bytes. So you'll be loading 2D and the next byte, which is 40, automatically, because you will be taking 2 bytes, starting from that byte. So your answer will be 2D 40, because you'll be taking 2 bytes, starting from that byte. So, you know, whenever it's 2 byte, we will always tell you the address of the first byte, because, you know, we don't have to give you the address of all the bytes. We'll just tell you, okay, this is the address, so that means that address, whatever you have there, next one. So you'll take that byte, next byte, because this time you'll be loading 2 bytes. Remember, the except A and B, all the registers are 2 bytes. All the general purpose register. Except there is another one, so we'll talk it later, but most of the ones that you use, because, you know, I don't want to complicate at this point, so the one that we'll be using except accumulators, everything is a 2 byte, except there is one more, which is. So if you are done with the quiz 2, you are ready to start this one. Any question? I think you will have some question over the time, and you can, you know, when you practice, submit, see the answer. We are here, so we can answer. So let's try this. So let's stop our lecture here, and then, so remember, this is a continuous lecture, so we'll stop it here, and we'll continue from here, because there are plenty of things are waiting and coming, okay?